Adding nutrients to your soil in the form of fertilizer is one of the most common practices in agriculture and gardening. But do you actually know what you are adding and how to measure whether your soil's nutrients are in the right range? Today we are diving into what nutrients really are and what the EC value has to do with them. Welcome back to FreshKtown. When you add fertilizer, you've got two main choices: synthetic or organic. Organic fertilizers, like compost, manure, or plant-based inputs, don't deliver nutrients directly. You are usually adding organic matter where nutrients are still locked up in complex molecules. Microorganisms and fungi in the soil then break those down, releasing nutrients in a form plants can actually use. Synthetic fertilizers skip the middlemen, or better said, skip the middle microbes. You directly provide nutrients in a form that's already plant available. That's why synthetic fertilizers usually work much faster. You will see effects almost immediately. Organic fertilizers, on the other hand, might take a few weeks to kick in. You have probably noticed those three numbers on your fertilizer bottle or bag. Those are N, P, and K. Nitrogen, phosphorus, and potassium. They are the three primary macronutrients, meaning plants need a lot of them, which is also why they're always front and center. And in the case you have ever wondered, yes, potassium is K. And that's because its symbol in the periodic table is K. But plants need more than just NPK. They also need secondary nutrients like calcium, magnesium, and sulfur, plus micronutrients like iron, zinc, manganese, and many others. All of them are essential. They are just needed in smaller amounts. Still, NPK gets the spotlight because they are the nutrients that tend to have the biggest influence on plant growth and are most likely to be deficient in soils. Now, here's where it gets confusing. It is not just about whether the element is there, it's also about how it is there. Take nitrogen. It can exist in multiple forms: ammonium, NH4, nitrate, NO3, nitrite, NO2, or even atmospheric nitrogen, N2. Of those, nitrate and ammonium are the ones plants can actually absorb. Though in high concentrations, ammonium can actually become toxic. Which form is available depends on different factors like pH, oxygen, moisture, temperature, and how active the soil microbes are. Compare that to potassium, which is usually present as a K+ ion, simple, stable, and easy for plants to absorb. So even if nitrogen is in your soil, it might not be in the right form for plants to use. Alright, with the nutrients out of the way, let's talk EC, electrical conductivity. EC is a measure of how well electricity can move through a solution. In our case, it is a value to estimate how many plant-available nutrients are floating around in our soil, water, or hydroponic solution. But why EC, you might be wondering? Because all those nutrient ions, like nitrate, NO3-, and potassium, K+, carry electrical charges. And the more charged particles in your solution, the better the electrical conductivity. So in simple terms, higher EC means more dissolved nutrients, and low EC might mean your plants don't have enough nutrients available for uptake. Electrical conductivity is usually measured in millisiemens per centimeter or microsiemens per centimeter. Now, to be honest, I've seen EC measured in all sorts of units. deci, milli, microsiemens per centimeter, sometimes even per meter or millimeter. But in general, they all display the same thing: how well electricity moves through your nutrient mix. Just check your device to see what it's using so you can correctly interpret its value. Now here's the kicker. EC doesn't tell you which nutrients are in there, only how many total ions are present. That means it's totally possible to have a good EC reading while still being deficient in something important. That's why EC is a great starting point, but it won't replace a full nutrient test or good observation. So that's the basics of what nutrients actually are and how EC ties into the whole story. It's a tricky topic, I know, but I hope this gave you a solid starting point. If something is unclear or you have any further questions, make sure to write a comment. Otherwise, if you enjoyed this video, don't forget to like and subscribe. And until next time, keep on growing. Peace.